Hi guys, welcome to this video. So in this video, we are going to create this G-clamp using Creo parametric. Okay. So I have searched for various diagram on website or I have asked my friends. So I think like they don't have any kind of exact dimension for this G-clamp. So I have created this entire drawing myself. So this is just for your practice, guys, because this is not a exact dimension as per the industries. Okay. So I'm just going to model this based on my own dimensions. So for sharing it to you guys, so I just have created a drawing for this. So I will share this drawing link on the description. So kindly go and check if you need to get on practice with this, okay? And also I will attach all the parts and assembly part which I am going to do in this video in this below video link, okay? You can go through our channel website or else like you can directly go for the alternative link and then you can access these files, okay? So yeah, it has over 1, 2, 3, 4, 5, around 5 parts. Okay, so let's go on with this. Okay, so let's go and create our working directory first because we are going to create around 5 models for this, right? So let me create a new folder. I'm going to rename this as G-clamp. Okay, and then click on OK. Okay, so now we can directly go for the new. And for the first part, we need to create this clamp jaw, right? So yeah, so let's rename it as clamp jaw and let unclick the default template and let's select our default template as MMNS spot solid ABS. Okay, so let's see the diagram first. So let's zoom into this. So this is the profile that we are going to create now as for part 1. Okay, so yeah, so total height is 100, total width is 125. Okay, so let's go for the front extrude, or else like you can directly go for the sketch. Okay, so I'm going to draw a corner rectangle like from here till here, and this will be 125 and this will be 100. Okay, I think it's right. 100, 125, 100, 125. Okay, so let me just drag it towards outside. Okay, so now we need to create this surface. Okay, so for this, at first we can create this round feature. So this round is as a radius of 30, so we can directly go for this and we can create a fillet for this, right? So select this and this and this and this. Okay, so let me adjust this radius as 30 and this as 30, right? Okay, so then we need to create this inner surface. So this has a distance of 75. Okay, and this distance as 25. Okay, good. So let me keep a point from here and like this, and this distance as 25 and this distance as 25. Okay, now we can directly draw a line from here till here and from here till here. Okay, and like yeah, like in the diagram this mentioned like this distance is 75, right? And you can see this is same as 75 here. Okay, and yeah, it will be the same as 25 as the width of this. Okay, so I'm just going to draw a line like this and then this total distance as 25, and then now we can able to delete the unwanted lines which you don't want, right? And the top line also. Okay, so then we need to create this cross feature for this. Okay, so for this, after the distance of 5 we need to draw an angled line at a distance of 30. Okay, so before that let me just plot 2 points like this and like this. Okay, and yeah, this distance will be 5 and the height will be 30. Okay, so this will be 30, and then we can directly draw a line between these 2 points and then let's delete unwanted segments here. Okay, and yeah, then I think we have done with our sketch. I think so. We have completed this profile, but we need to create this extruded part afterwards. Okay. So, yep. So, yeah, this extruded value is of 8. Okay. So, let me just extrude this. So, as a symmetric extrude, as a value of 8. Okay. So, let me just turn on the shading with edges. Okay. Okay, it looks good. Really good. And then, like, we need to create this rib feature, as you can see here. Okay. So this extrude length is 20, but before that we need to see the sketch view. So okay, so sorry, like we need to create a round feature for this as a radius of 10. So yeah, let's go for the section here, and let's add some fillet for this also, and from this to this. So this is 10 and this is 10. Okay, and so this distance is 5, right? So all the distance will be 5, so we can able to take a offset for this. So let me just select this front plane, directly going for the extrude, and at first I'm going to project all these. Okay, good. So now we can directly go for the offset loop and select this entire loop. Okay, so I need in backwards direction, so I'm just going on with the negative value of a value of 5, and then let's close all this. Okay, and let's draw a line to close this. Okay, we all done with our sketch, so let's go for the extrude. I'm going to extrude this on the both sides. I don't want it as a remove material feature. And let's see the extrude length. I think it will be 20 here. Yeah, 20. Good. So let's go and enter a value of 20 here. And then let's click on OK. So, yep, like we have completed this profile, but we need to create this circular profile here. Okay. So, okay. So here it has around, let me just zoom this. Okay. It has a round of radius 10. Okay. So, yep. So at first, like let me see this for one more time here. Okay, so I think there is no distance for this, so we can able to create with our own itself. Okay, so let's go here, select the surface, and let's go for the extrude, the extruded view here. So at first, I'm going to draw a 3-point tangent arc like this and like this. Okay, and yep, this total height will be 100. Okay, so it is placed on this reference, right? So yeah, let's see whether this radius value is 10 as they mentioned. Yep. Okay, so 10. So then we can directly subtract the minus value of 10 here, and then it will be placed on this reference. Okay, so good. So now, yep. So now let's delete all these unwanted segments and then click on OK here. I need as a remove material feature for both the sides like this, and then OK. So now let's select the surface again, go for the extrude, and then go for the extruded view here again. And now I'm just going to take a reference for the circle, and on this center point I'm going to draw one more circle for the hole. Okay, let's see, this radius as 6. Good. So the diameter value will be 12. Okay, so now let me just draw a line yeah, to our own. So I'm just going to enter a value of 15 here. Okay, it looks good. Okay, so now we can directly project this, this, and this. Okay, and draw a same line, equal constraint like this, and then let's close this. Okay, so now I don't want the circle. I'm just going to delete this. So this is just for the reference for me, and then click on OK here. Okay, So let's see the extruded value length of this. So it will be 25. So we have drawn from the surface, right? So it will be 20. Or else like you can directly go for the select surface, you can directly select the surface. Okay. So now we have completed our profile as you can see here. Okay. So we need to create this hole, right? So I'm just going to select this surface, extrude, and go for the extruded view. And let me just take this as a reference like this. And yeah, I'm going to draw a circle with the diameter value of 12 and then okay. So we need to flip the direction and let's keep this through all extrude. Okay. So now we have created our first part. I think like we have covered all these dimensions as you can see here, right? Yep. So what else do we need to add here? Yeah, we have a note here. So this as an internal thread with extrude cut of equilateral triangle 1.5 mm and with a pitch of 1.5 mm. Okay, so we need to create an internal thread for this. So for this, like we can use because they have provided a pitch value, so we can directly use the helical sweep option here. So yeah, so this will be the internal thread with an extrude. So we need to create an extrude part. We don't want it as a here it is mentioned as extrude cut. Okay, so let me just go for the next part here. So this will be the extrude. Okay, so for this we need to create as an extrude cut feature. So yep, good. Let me just select this center plane and go for the sketch and then go for the sketch view. So here at first I'm going to take a reference for yep, select this line and this top line and this center line. Okay, so let me just draw a line from here to here and another center line for the helical sweep tool. Okay, so then click on OK. Let's go for the helical sweep and yeah, thread direction will be from the left side. So then directly go for the sketch and then sketch view. Okay, here we need to draw like from here. Okay, good. Okay. Okay, here you can see this is an extruded part. This is not extrude cut. I think I have some error in this diagram. Okay, so here we have an extrude cut option because you can see here it is got cut feature on this. Okay, so we need to use extrude for this and extrude cut for the second part. Okay, so okay, so we can directly draw a rectangle. Okay, so let's draw a line from here till here like this, and then let's make it as an equilateral triangle, like equal on all the sides, and then we can add this value as 1.5. Okay, it looks good, and then okay here. Okay, so now we can see there's a more gap on this, so I'm just going to reduce the pitch value to 1.5, and then you can able to see it looks really good, right? And then we don't want to worry about this part because after getting extrude we can directly delete this part. Okay, and yep, it's fine. So I'm just going to click OK here. If you need this you can directly delete this, so I'm just going to select this as an extrude, go for the extruded view, and let's take a reference on this, and then let's draw a line like this, and then let's delete the unwanted segments on both the sides and remove material, and then OK. So now you can see our internal thread has been created by using extrude tool. So yep, so good, we have completed our first part. So now we can directly save this part. So let's save this part. Okay, save. Okay, so now we can close this and let's create our second part. And for the second part, yeah, it is spindle. Yep, so let's rename it as sorry, Spindle, and unclick the default template and template as a spot solid ABS. Okay, so it's a kind of very easy part, but we need to create a helical sweep for this also with the same triangle, and here we need to create as an extrude cut for this. Okay, so yeah, okay, so now we can create this first part. This has a radius of 10. Okay, so diameter will be 20 and the extrude of 22, right? Yeah, so let's go for the top. Sorry, yep. Let's go for the top and sketch view here, and then let's draw a circle with the diameter value of 20. Okay, so now let's extrude this to a value of 22, and then okay here. Okay, and then like we need to create this circular extruded part. So this diameter will be 12 with an extruded value of 96. Okay, so let's select this surface, extrude, and go for the sketch view. Here the circle diameter will be 12 and extruded length as 96, and then okay here. Okay. So then we need to create this small circular part, is diameter as a value of 6 and extruded length of 12. Okay, and let's go for the extrude from the surface, and then let's draw a circle, the diameter value of 6 and with an extruded length of 12. Okay, so now we have completed this profile. um, and then like what else do we need? Yeah, we need to create this chamfer value of 2. So let's go for the chamfer and enter a value of 2 here on the surface, and then okay here. So then we can directly go for this helical sweep feature. So for this, like you can able to see, so this has an external thread extrude with a triangle value of 1.5 mm and with a pitch of 1.5 mm. Okay, so we can directly go for the this front plane. Let's go for the sketch and then go for the sketch view. So here like we need to create an extruded cut feature, so I'm just going to draw a line from the start to the end. Okay, or else like yeah, let me just keep a point here, and then let's enter a value of 5 at the distance, and then let's delete this because like you can able to see like not all the threads will be created from this edge. It has some distance and it will be created from that to the edge. Okay, so here in this like I don't have mentioned any exact dimension for this, so we can able to go with our own like with a distance of 5 here. Okay, and then like for this we need to create a center line for the helical sweep, and then okay, then we can directly go for the helical sweep here, and the thread direction will be from the bottom, and let's go for the sketch and let's go for the sketch view. So here it will be the extrude cut option. So I'm going to draw a triangle towards the inner side, and let's make it as an equal on all these 3 sides, and let's adjust this value as 1.5. Okay, so I just want to tell you one thing guys, like if you are going to create any thread feature without using like you can able to see while we exit this sketch option, you can able to see a thread feature on this like cosmetic threads. If you are using that thread, that there will be no problem while you are creating thread for 2 parts, and then you are going to assemble that part, means that will not create impact on your part. So if you are going to create a thread manually by using this helical sweep, like you need to prepare the value for this triangle, or it may be the circle, or it may be a square, but you need to keep the value as same for which you have done for the previous part, and including the pitch value. Okay, so we have entered a value of 1.5 here, and let's go for the remove material, and you need to add the same pitch value which you have entered for the previous part, right? So then only it will be very easy, and the model will be generated only if you are using the same value here. Okay, and 1.5, and you can see this like it looks really good. and yep, I'm okay with this. So let's click on OK here. So now we have completed our second part, and let's check whether we have missed any kind of dimensions here. Okay, I think I have covered everything. Yeah, but we need to create this whole feature as a radius of 2.15. Okay, good. So let's select this right plane. Let's go for the sketch view here. I'm going to draw a circle like this, and let's see whether we have any dimension distance for this hole. Yep, we don't have anything. Like instead of that, we need to place this as a center point, so we can use this 22 value here. Okay, so let's have a 22 divided by 2. It will be a center point for this extrude, right? And then for this we have a radius value of 2.75. So 2.75 multiplied by 2, that will be the diameter, right? So yeah, 5.5. Good. So let's click on extrude, and let's make it as a symmetric extrude. Anyway, we are going to create a whole feature for this, so we don't want to add a depth value for that. So I'm just going to click on OK here. Okay, it looks good. It looks good, really good. So we have completed our second part, so we can just save this part. So let's go for the save. Okay, so let's move on for the next part. So for the next part, I think it is very simple. Like it is a handle part. Okay, so let's go for the new and enter the name as handle, and click the default template, and let's select the unit as spot solid ABS. And I'm going to move on for the top sketch extrude, and here we have a circle of the same radius value as 2.75. We have created a hole right here, right? And with the distance of 96. So let's draw a circle like this, and let's enter this as 2.75 multiplied by 2, as it is 5.5. Okay, so now let's extrude this as a symmetric extrude, and let's enter a value of 96 as a length for this. Okay, so then click on OK here. I think that's all with this third part, so we can directly go for the fourth part here. Okay, this spindle cap. Okay, so now let's save this part as our third part here, and then let's close this. Let's go for the new, and this will be the spindle cap. Okay, spindle cap, and let's unclick the default template and then click on OK here. And the unit as I'm on a spot solid ABS. Like I will tell you this particular thing in every video while I'm doing assembly. Like if you are going to create any parts, like more than one part, if you are going to create in two or more parts, you will need to select that template, right? So you guys need to follow the same template if you are going to assemble all these parts. So you may have a particular template which you are going to use. Like I will highly recommend you guys to use spot solid ABS, or else like if your organization or if you have any works based on mmks or mmns part solid realistic, you can directly go for that. But other than that, you can directly use this ABS part, because it doesn't have a big role while you are creating a part. If you are going to use the same template for all this part, nothing will have nothing will be created as an impact for your part. Okay, so yep, so we can directly go for the fourth part here. It's a spindle cap. Okay, I think these images are not clear, so sorry for that. Like I don't have much time for creating this drawing, so I have created all these like a urge thing, so sorry for that. And for this, like we can use revolve tool, because I think all the 360 degree it will be same. Okay, it will be circular part, so we can use revolve tool for that. So yep, so yeah, so this height as 20, and this will be 14, 2.5, 11, and this distance is 3. Okay, okay, so now let's go for the front plane sketch. Let's go for the sketch view here. So for this, like we need to place a center line, because we are going to use the revolve tool, right? Okay, at first let's create this profile first, and then we can able to assign our dimensions here. Okay, it looks good. Align from yeah, from here, like this, like this, like this, and like this. And I don't want this equal constraints. Okay, so this distance will be 2.5. Okay, sorry, so this will distance will be 3, and from this dotted line it will be 2.5. Okay, good. 20 and 14. Okay, so from here till here it will be 14 divided by 2. Okay, and from here till here it will be 20 divided by 2. Okay, and then this distance will be 2.5, and this distance will be 3. Okay, and then do we have exact length for this? Okay, okay, I think I have missed with this dimension because like I said before, like yeah, we need to create this by our own. So I think this distance, like from here till here, like it will be 13, and yeah, okay, let's go for this. Okay, yeah, okay, so dimensions from here till here, it will be 13. Okay, so then like from here till here, it will be 10. Okay, good. So then we need to create this line. So for this, like from here till here, so this will be 11 divided by 2, and then we can directly join a line like this, and then we can complete our sketch. Okay, 2.5, 7, 10, and this will be 13, and yeah, from this point till here it should be 10, and this will be 5.5. Okay, good. So let's click on OK, and let's go for the revolve. Okay, it looks good. We have completed our part here, and then we need to create a whole feature for this. So for that we have a radius value of 3. So let's click on the surface, extrude. Let's go for the extruded view here, and let's enter a value of yeah, radius value of 3. So diameter will be 6, right? So then click on OK, flip the direction. Let's give this as a through all extrude, and then OK. So now we have completed our fourth part. So let's save this part, and let's close this, and let's go for our final part. So this will be the cup handle here. So this will be like very simple. Okay, so let's go on new, name it as cup handle, and unclick the default template, and here select same again as spot solid ABS. Let's go for the top extrude, go for the extruded view. Here the outer circle, it is a radius of 4, so the value will be 8, and yep, like it has a value of 8, and total distance is 10. Okay, so let's go for the circle, and we enter the diameter value as 8. Okay, and let's extrude this to a value of 10 as a symmetric extrude, and then okay, and then as a chamfer of 1.5 on this edge. So chamfer 1.5 and this surface, and then okay. So now we need to create a whole feature here, as they have mentioned this old dia as 2.75 into 2 as a diameter. Okay, and this depth as a value of 6. So select this surface, extrude, and then go for the sketch view. So here I'm going to draw a circle with a radius value of 2.75, so that should be multiplied by 2, so it will be 5.5. Okay, so this depth value is 6, and then let's click on OK. So we have completed our final part, so let's save this part. So then we can directly go for the assembly. I think like we have covered all these parts. So good, we have done all this. So yeah, let's click on new, let's click on assembly, and let's name this assembly as yeah, G clamp ASM, and let's click this as unclick the default template, and let's select the template as ASM design ABS. Okay, so now let's go on for assembling our part. So the first part will be the clamp jaw, and let's place it as a sorry, let's unclick this. So we need to make this as a default. Sorry for that. Let's go for the default and then click on OK. If you are going for the fix option, you can directly go for that because these two are similar, but I will use this normal default function for the first part, which I'm going to place on assembly. Or not for this, if I'm going to place any kind of assembly, I will use the default for the first part, and that I'm going to assemble here. Okay, so then for the second part, let's go for the sorry, yeah, spindle. Okay, it looks good. So for this, I'm just going to use a cylinder. Let's turn off all this except the axis. Okay, let's select this axis, and yep, okay, and then this axis, and let's drag like this. So my first constraint is okay, but I need to rotate this part. Okay, so I'm just going to use I'm going to create a new set for this, and I'm going to create a solve slot function because we have to merge all these threads into this thread, right? Okay, so I think like we have missed something. Yep, I think I have forgot with this because your point need to be placed at the outer thread to provide a slot function. Sorry, so I have forgot about that. So let's close this, and let's open this part. I need to create a point feature for using a slot function. So I'm going for the point, and I'm just going to select this entire thread, and then I'm directly going to click OK here. Let's go for the point display, and you can see a point is created here. Okay, so let's save this part, and let's close this, and now we can able to view this point, right? So now let's go for the assemble, let's go for the spindle, and let's go for so now as the same cylinder, this axis and this axis. Okay, sorry, I forgot to flip this model. Okay, I need to flip it like this, and then let's select this axis and then this axis. Okay, so let me just drag it towards the end like this. Okay, so now I'm going to create a slot function for this as a slot mechanism. So let's go for the new set, and let's select this slot, and now like we need to select the component item. So for the component item, I'm going to select all these entire thread. So starting with this, I'm going to select this entire thread. Okay, so yeah, you guys may have a doubt why we are selecting all these threads, because we have a created point on this thread, right? So we are going to follow this entire thread towards that point so that it will have some exact thread function. Okay, so not for this part. If you are going to create any thread function, like if you are going to create any analysis or a mechanism for your part, you guys need to use this both the cylinder function and then a slot function. So then you can able to rotate this entire part by creating this thread. Okay, I think yep. Good. Entire thread we have selected around 16 items here. Can go and check on this whether we have selected all these threads. Okay, good. So now for the assembly item, I'm just going to select this point, and then you can able to see our connection definition is complete, and then we can directly close this because we have completed our slot function. As you can see here, it is got all these thread. The thread start point will be placed on the point which we have created on the assembly. As you can see this curve feature here, right? So yep, um, I think you guys can able to understood this feature because I have previously posted a video on the jack feature for that. So I'm just used the same feature on that part. I think you guys have already seen that video before. If you are not seen that video, kindly go and watch that so that you will have some idea based on this slot function and then the angularity function for the rotation axis. Okay, so or else like if you have uh, even if you have watched my video and if you have any doubt means you can directly comment below so that I can able to put a separate video for this slot function, how this can be worked and what are all the other ways to create this slot thread function. Okay, so yep, we have completed this, so let's click on OK here. And yeah, so now if you go and drag this component, you can't able to move it like back and front. You can just you need to rotate this, so then our part will be moved towards inside, like you can able to see here. If I'm rotating like this, our part will be moved here. Okay, yep, I think like you guys can able to see this. Okay, so why I'm doing like this means because we need to place some other part here. Okay, so I'm just okay, let's close this and let's assemble all our parts here. Okay, so for the next part, like yeah, let's go for the handle part. So let's click on open here and let's select a plain display for this. And you can directly use your user defined like axis function and the plane function, but for reducing the time constraint, I'm just directly going to use the pin function for this axis and for this axis. Okay, and for the translation, I'm just going to select this plane and this front plane. Okay, okay, it looks good. So yep, I think like we have done this. Let's rotate this. Okay, it works. So let's go on for the next part. So for the next part, spindle cap. Okay, so we need to place this. I'm going to use the same. Okay, I'm just going to use the same pin for this also. Select this axis and select this axis, and then select this face, and then select this back face. So, yep, it looks good. So let's click on OK here, and it got placed. Okay, so let's assemble our final part. So let's turn on all this except the axis. And if you go for the point display, like you can able to see the point here, right? You can able to see this. Okay, so let's turn off the point and let's go for the axis display and let's assemble the cup handle. Okay, let's drag this near to the spot and I'm going to flip it like this, and I'm going to use the same pin for this. Okay, let's drag it like this, select the surface and the inner surface. Okay, so I recommend you guys to not use this pin mechanism because this pin mechanism, if you click OK here, you can able to see the small tiny box here. So it is nothing but our part is not fully placed because it has some rotational axis. We can able to rotate this part. Okay, so for reducing the time, I'm using the pin mechanism. So if you are going to do this as your project, I recommend you guys to go on with this user defined for this, and then you can able to place this point on all these three axes, like selecting the axis and selecting this face and then selecting the plane here. Okay, so I'm going to do the same on the other side. So I'm just directly going to repeat this and select the axis and surface and add, and I'm going to select this axis and this surface. So now you can see a part has been created. So I think like 1 2 3 4 5 and then 6, like we have assembled all the parts. So let's go for the motor and then let's create a motor for this. Okay, so before that I'm going to give some appearances for this, and color for this entire part, and green color for this part, and yeah, yellow color for this. Okay, and yeah, let's give the same yellow color for this also. It looks good. And then blue color for this handles, and for the top cup handle I'm going to use the white color. Okay, so this color doesn't look good, I know, but for the visualization I'm going to use this, because by using different colors we can able to see the exact motion of the part, right? So for that I'm using this. Okay, so now we can go for the motors. So let's go for the application mechanism. Let's go for the servo motors. But before that, when we enter into the mechanism, we can able to see the pin joints which we have used for all these parts. You can able to see this, right? So because of this I said, like, you guys don't want to use pin mechanism for the normal parts. If you are going to rotate any part, you can directly, or if you are going to add any motors for your part, you can directly go on for the pin. Otherwise you can directly go for the other constraints, like a cylinder or like a user defined function for that. Okay, so let's go for the servo motors. So I'm going to select this axis here. So here you can able to see, like, I can't able to show this. Yeah, if I select this axis, this pin mechanism, you can able to see the only position here. So it will it will never work like if you are going to rotate this part. So we need to select this small curve, and then you can able to see the angular position here, or else you can directly go for the reference, like connection for the first rod and axis. If you select this axis, like, let me just undo this, you can see that this is a first translation axis. So if you are going to create for the translation axis, you can't able to create, or you can't able to rotate this part. So I will highly recommend you guys to use this as an angular position as a first rod axis. Okay, so now we need to flip this, because we need to move our part towards this direction, right? So then for the profile details, angular velocity, and here I'm going to add a value of 30 and then click on OK. So now we have created our motors, so we can directly go for the mechanism analysis, and let's zoom this part. Okay, so kinematic view, and then let's enter this as 100 and this as 20 at first. Okay, so now you can see our part is created and it is rotating good. Okay, yeah, it looks really good. So if you are going to use as a normal position for this, as a normal velocity, like I said before, when you're creating a new motor, this part will be not rotated. You may have a pop-up window, like your part will be um, can't able to regenerate it, so we need to ignore or we need to stop that. Okay, so I'm saying that there's a possibility for that. So I will highly recommend you guys to select this uh, normal axis, not a translation axis, right? So let's enter this, and let's enter a value of 10 for speed up. So yep, so that's all guys, so thanks for watching. So if you want more videos related mechanical engineering or any other content, or based on a specific tutorial for any other tools, you can comment below and I will put videos based on that. Okay, so thank you guys, like we will see next video. Until then, bye.